This question is from topic relative velocity. Here in this question, it's been told that relative to an origin O, the position vector of point A is 5, 4, position vector of point B is minus 10, 12, and position vector of point C is 6, minus 18. All the distances are measured in kilometers here. It also says that a man drives at a constant speed directly from A to B in 20 minutes. For the first part of this question, we have to calculate the speed in kilometer per hour at which the man drives directly from A to B. Now let's write all the data that we have in our hand from the question. We have three position vectors, so let's write the first position vector OA is 5, 4. The second position vector OB, the vector OB is minus 10, 12, and the third position vector, that is OC vector, is equal to 6 minus 18. Now we have to find the speed. We know that speed is distance over time, so let's write speed is equal to distance over time. What is the distance here? It would be the magnitude of the vector AB, that means the modulus of vector AB, divided by the time, which is here, is equal to 20 minutes. Now, how can we get the distance from a vector? Let's say that we have a displacement vector V as AB. Then the distance covered by this vector would be square root of A squared plus B squared. We are going to use this formula. Let's try to find the AB vector first. AB is vector OB minus vector OA. Now let's put the values here. Minus 10, 12, then minus 5, 4. Minus 10 minus 5 gives us minus 15, so let's write minus 15. And 12 minus 4 gives us 8, so let's write 8. Now we got the vector AB, so let's try to find the distance from A to B, which is equal to modulus of vector AB, which is equal to square root of minus 15 whole squared plus 8 squared, which is equal to, would be square root of 289 is equal to 17. So the distance is 17 kilometer. Now let's deal with time. Time is given as 20 minutes. Let's try to convert it into hour. So let's divide it by 60. So 20 divided by 60 hours, which is equal to 1/3 of an hour. So we got the time in hour. Now finally the speed will be equal to 17 kilometer divided by 1/3 of an hour, which gives us 51 kilometer per hour as the speed from A to B. So we have found the speed. First part of this question has been done. Now let's move on to the last part of this question. Here the man, for whatever the reason, drives directly from B to C at the same speed. That means with the speed of 51 km per hour. And for this part of the question, now we have to find the time he took to reach directly from B to C. Time is calculated by the equation distance over speed. So let's write distance, which is here would be the modulus of the vector BC, and we know that the speed is here, so speed is 51 kilometer per hour. Now let's try to find the vector BC. The BC vector can be written as the position vector OC minus the position vector OB. Now let's put the values again. So vector OC is 6 minus 18 minus vector OB was minus 10, 12. So that gives us 16 and minus 30. So we got the vector BC. Now let's try to find the magnitude of the vector BC, which will be the distance here. So it would be equal to square root of 16 squared plus minus 30 whole squared, which is equal to 34. I use the calculator obviously. Now time is equal to 34 divided by our speed 51. Now 17 is the common factor for both 34 and 51. So let's divide. 34 divided by 17 gives us 2. So let's write 2. And 51 divided by 17 gives us 3. So let's write 3. So time is 2/3 of an hour. So we got our time. Let's convert it into minutes by multiplying 60. So now it would be minutes. 60 divided by 3 and the result is 20. 2 times 20 gives us 40 minutes. So it would be 40 minutes. So we have found the time the man took to reach directly from B to C. This question has been done. Now let's move on to the next question, please.